Question number 9. The lines L and M have the vector equation. First equation is r is equals to minus I plus 3j plus 4k plus lambda times 2i minus j minus k. And second line having the position vector, that is r is equals to 5i plus 4j plus 3k plus mu times ai plus bj plus k. Find the values of a and b. A and b are the constant, and you have to show that if both the lines that are L and M intersect actually, then that gives you 2b minus a is equals to 4. This is the question from our vectors. So first of all, you must have to be sure about position vector, that is definitely denoted by r. That is the sum of magnitude plus line, that is basically the direction of line actually that shows. So every position vector is a combination of two things. First one is a magnitude and other one is showing the direction actually. L means direction and M means magnitude. Position vector is a sum of both quantities. So my first step should be defining L and M for each of the equation. This is for example equation number 1 and this is my equation number 2. My first step should be defining L and M for each of the equation. So from the first equation I can say my L would be minus 1 plus 2 times by lambda, 3 minus lambda, and 4 minus lambda. This is the L from this equation, that is capital R, from this equation number 1. Second equation shows me the M, that is denoted by M, and from this one I can say it would be 5 plus mu times by A, 4 plus mu times by B, and 3 plus mu times by 1. So that gives me L and M. Then I have to construct the equation. I have to compare the I coordinate of L with I coordinate of M, and J coordinate of L with J coordinate of M, and K coordinate of L with K coordinate of M. This is my I, this is also I in a direction way. This is J, this is also J. That is K, and that seems to be K. So let's do the comparison. Let's compare the values of I and I for L and M and J respectively. So that gives me minus 1 plus 2 times by lambda, which is equals to 5 plus A times by mu. Second, 3 minus lambda is equals to 4 plus mu times by B. 4 minus lambda, which is equals to 3 plus by mu. I have to solve this equation definitely in order to find the values of A, B and C. So I can say I can substitute, I can simplify these expressions to get my values. The first equation, that is denoted by this red marker, it can be simplified in a way: 2 lambda minus A times by mu, which is equals to 5, and 1 is shifted onto the other side, that gives me 6. 5 plus 1 will be 6. Second equation gives me minus lambda minus B times by mu. I shift B times by mu onto the other side, so it would be minus B times by mu, which is equals to 4 minus 3 would gives me 1. And third equation can be written as minus lambda minus mu, which is equals to 1. Further I can do more simplification, and the first equation could be written as 2 lambda minus A times by mu, which is equals to 6. That is equation number 3. Second is lambda plus B mu, which is equals to minus of 1. I took minus common and then shift on to the other side from this equation. That gives me equation number 4. And last one would be lambda plus mu is equals to minus of 1. That is equation number 5. So as a whole, you just do conversion and write the relevant things together with a positive or negative sign, and at the last you have equation number 3, equation number 4 and equation number 5. These are the required equations. Now the question arises, what I can do next in order to find the values of a, b and c. Simultaneous method can also be applicable in order to find the value if you want. If you want to use substitution method, then no issue, you can also do simplification and solve it by substitution method. So I wish to do substitution method over here, so that's why I just consider equation number 5, and that gives me lambda is equals to 1 minus mu. I shift mu onto the other side now. So lambda is equals to 1 minus mu. Then I substitute lambda is equals to 1 minus mu in equation number 3 and equation number 4. So let's plug. Lambda is equals to 1 minus mu in equation number 3 and 4. So let's see what happens. That gives me 2 times by 1 minus mu minus 8 times of mu, which is equals to 6. And second equation, that is lambda plus b mu, that gives me 1 minus mu plus b times by mu, which is equals to minus of 1. So further, that first equation can be written as 2 minus 2 times by mu minus 8 times by mu, which is equals to 6. And further it can be written as 2 can be multiplying inside and together the terms relevant. And second equation can be simplified and can be written as b times by mu minus mu, which is equals to 2. I just shift minus onto the other side, so that gives me minus of 2. So up to this point, I think so the things are clear to you. Now what I can do next, for example, this is my equation number 6 and that is equation number 7. I have to divide equation number 6 and equation number 7 in order to get my result. Sorry, here is some bad. 2 minus 6 minus 2 would be 4 over here. Instead of 6, there should be 4 in equation number 6. So let's divide equation number 6 with equation number 7. So whenever you do division, your answer will be converted into mu times y 2 plus a, which is equals to 4, dividing by mu times by b minus 1, which is equals to 4 dividing by 2. Yeah, mu is cancelled with this mu and 4 is cancelled with this 2 and can be written as 2. So as a whole, you can say 2 plus a over b minus 1, which is equals to 2. You can do cross multiplication in order to find the values of a and b, and after cross multiplication you have a minus 2b, which is equals to minus of 4. Yeah, a minus 2b, which is equals to minus of 4. And I have to show that 2b minus a is equals to 4. There is a reversible sign of minus, so you can multiply both the sides with minus, and that gives you 2b minus a, which is equals to 4. That is the required result, this one, 2b minus a, which is equals to 4. Up to this point, you just figure out, you just show the result, and for the second part you have to find the values of a and b, in which you will take advantage of the first part and find the values. So let's do. It suggests that given that L and M are perpendicular, so find the values of E and B. You know that whenever both the lines, either L and M, are perpendicular, their dot product will be 0. So I have to write down the coordinates of L and M respectively. So that gives me 2 minus 1, 2 minus 1 and minus 1. These are the coordinates of L. Coordinates of M would be, because we are talking about direction, so that part could be took now, lambda part. So lambda and mu part. So A, B and 1 are the points coordinates for M, you can say. A, B, 1. That should be equals to 0. I know that. So as a whole, after dot product, you can say it would be converted into 2A minus B minus 1, which is equals to 0. 2A minus B minus 1, which is equals to 0. Yeah, I know that 2B minus A is equals to 4, right? 2B minus of A, which is equals to 4. I know this result by the A part. So from this figure, I can see from this equation A is equals to 4 minus 2B. A is equals to 4 minus 2B. So at the place of equation number, for example, star, this is marked as equation number star, put back the value of A in this equation number star and do the simplification. That yields 2 times 4 minus 2B minus of B, which is equals to 1. 8 minus 4B minus 2 is equals to 1, and that gives me 3B is equals to 9, because it is shifted over here, and that could be written as 3B is equals to 9, and further B would be equals to 3. I figure out the value of B. Now put back the value of B in this equation that is highlighted with this green marker. At the place of B, put down its value. That gives me 4 minus 2 times by 3, which is equals to A. 4 minus 6 would be 2, so A seems to be 2. So I did calculate two values of A and B, that is A is equals to 2 and B is equals to 3. That is the answer. For the next one, A and B are these values. Use the find the position vectors for the point of intersection of L and M. Nothing is required over here, just use the values of A and B in the line L and M, and you can easily write down the position vector. So L would be equals to minus 1 plus 2 times by lambda, this one, and 3 minus lambda is the j coordinate and lambda is the k coordinate. So just put down their values over here. That gives me lambda value can be calculated first. Yeah, lambda value should be calculated first, and you can calculate lambda value from the mu one, because you know that the value of A and B. So mu times by mu times by A plus B, that gives me mu times by 2 plus value of A, that is 2, which is equals to minus of 4. So 4 mu is equals to minus of 4 and mu is equals to minus 1. This is the value of mu, and you know that lambda is equals to 1 minus mu under this green marker, this one, that one. So lambda is equals to 1 minus mu. So plug back the value of mu over here in order to get the value of lambda. Lambda is equals to 1 minus mu, and lambda should be equals to 2 over here. 1 minus 1 would be definitely positive 2. So position vector L would gives you 3, because 2 times 1 is 2. Lambda is actually 2 over here. So that gives you 2 plus 2 is 4. 2 times 2 is 4. 4 minus 1 would be 3. 3 minus lambda is giving you 1, and lambda would be equals to 2. So your final answer would be 3I plus j plus 2k. That is the answer for this L. This one. That is the required answer.